Welcome to MS45 e-learning platform. I hope you've heard of Newton's equations of motion, right? In this video, I'm going to teach you how to prove all the 4 Newton's equations of motion. And then after that, we will try and solve 1 or 2 questions to know how to apply them if in case you made them in your exams. So we are going before, let us consider a body with an initial velocity which is u is gaining a final velocity v after a time t. The body moves with a uniform acceleration a and covers a distance s. Therefore, the equations are as follows. Newton's equations of motion, we have equation 1 to be v is equals to, that is the final velocity is equals to u initial velocity plus acceleration times time. This is first Newton equation of motion. So equation 2, we have s, which is distance is equals to initial velocity times time plus acceleration times time squared over 2. So this is second Newton equation of motion. We have equation 3 to be v squared equals u squared plus 2as. That is equation 3. And we have equation 4 to be, that is also distance is equals to, we bring the bracket, we have v plus u on 2 bracket close times time. That is equation 4. But equation 4 is not somehow popular. Yeah, it's not that popular, but it is sometimes needed when especially the final velocity, initial velocity, and the time is given. You can use, without the acceleration, you can use this equation 4 to calculate for your distance, right? Yeah, proving equation 1. You know that acceleration is equals to change in velocity over time. So acceleration is equals to over time. Change in velocity, we have final velocity, final minus initial velocity on time. So mathematically, our acceleration here will be equals to final velocity v minus initial velocity, which is u, all on the time. We are making the final velocity the subject. We multiply both sides by t, so t multiply a equals v minus u on t multiplying t. This one will cancel t, making us at equals v minus u, right? We want v, so u go top, so to be u plus at equals v, right? It can also be written as v equals u plus at. So this is equation 1, right? Here we have proved equation 1. So we've done with equation 1. Equation 2, average velocity can be expressed as total distance over total time taken. Proving equation 2, average velocity is equals to total distance over total time taken. So average velocity over total time taken, right? In mathematically, you can do it like average total distance over total time taken. Let us name it as equation 1 here. And in most cases too, when the final velocity and the initial velocity are given out, you can find for their average. So mathematically, average velocity will be equals to final velocity plus initial velocity divided by 2. In other way, average velocity can be also calculated as final velocity plus initial velocity divided by 2. So this one to become our equation 2. So let us compare equation 1 and equation 2. To that we have S on T equals V plus U on 2, right? Let us make distance the subject, so we cross multiply. We are making L the subject. Let us do it simple, plus U on 2 multiplying by the T, our T the time, which is T, right here. So this one is our equation 4. We found our equation 4 over here. That is why in the beginning I said the equation 4 is not that popular, but it is sometimes needed, especially when the final velocity, initial velocity and time is given without acceleration. You can use this equation 4 to find for your total distance, that is the S. In the first equation, Newton's first equation, V is equals to U plus AT. Right here, we want to get rid of the V. We want to eliminate V. So our S will become, wherever we see V in the equation 4, let's substitute U plus AT there. So it will be U plus AT on 2 plus U here, multiplying our time. So therefore, to multiply the whole here, so ut plus at squared plus ut all on 2, right? Let's simplify things over here. Let us simplify things over here. Our S to be, you see, they are the same. So 2ut plus our at squared, our at squared all on 2. See that we can still simplify things, right? Yes, so our S now will be, this one will cancel here, leaving this one, at squared. So it will be ut plus at squared all on the 2 here. Yes, so this one will become our equation 2. Alright, so let us prove equation 3 on a fresh page, right? We know that average velocity can be expressed as total distance over total time taken, right? So average velocity so mathematically average velocity can be expressed as distance over time, right? So let us name this equation 1. And in most cases, when the final and the initial velocity are given out, you can find for their average. So mathematically, average velocity will be equals to final velocity plus initial velocity divided by 2. This is average velocity can be expressed as so mathematically average velocity can be expressed as final velocity, which is v plus initial velocity u divided by 2. So let us name this equation 2. So to this, let us compare equation 1 and equation 2. So we are going to have S on T equals V plus U on 2, right? So let us make S the subject. So S will be equals to V plus U on 2 times t, right? So this one can also be named as equation 3. We want to eliminate t from the equation, and in the Newton's law of motion, we have v to be equals to u plus at, right? So let us make t the subject here. So we are going to have v minus u equals 80, right? So we are going to have v minus u equals 80, divide both sides by a. So therefore our t will be equals to v minus u on a, right? Yeah, so wherever we found t at equation 3, we are going to substitute v minus u on a there. So we are going to have s equals v plus u on 2, bring your brackets, and t here, let us substitute all this here. So v minus u on a, right? So here mathematically we can use differences of 2 squared to simplify it, right? So we are going to have s equals v square minus u square all on 2a. So we are going to have we are making v squared the subject. We are going to have 2a s equals v square minus u square. So therefore our v square will be equals to 2as plus u squared. So this one can also be written well as v square equals u square plus 2as. That is it. That's the third Newton equation of motion. You can check it from this side. So guys, we've done proving all the 4 Newton's equations of motion. Yeah, we are going to solve questions on our next video. Make sure you subscribe to this channel and then you share it to your friends so that they can also enjoy it. Stay up to date. Thanks for watching.